Welcome, everyone. At Mimecast, we've been on a journey to adopt and move our application suite to the cloud. And today I wanted to share our experience as we went through the challenges while we were getting into this new uncharted territory. I am Amol Patil. I work at Mimecast. I work in the Quality Engineering and Services department. This project's been going on for a while, and there was no blueprint at first for us to figure out the transformation path, mainly because the product suite, which had a lot of apps, services, libraries, clients in them, had grown organically and inorganically through acquisitions and integrations over a period of 2 decades. So there was a lot of work, a lot of code, a lot of things that had to be considered while we moved there. It wasn't easy, but one thing was definitely that the functionality is not changing. There's no new feature. It's just the applications that currently operate on premise in a data center or multiple data centers globally. We're just going to move them to operate in the cloud platform. The most important aspect that we felt we should be focusing on is a fully automated code, test, deploy, and monitor way of doing things. Every time we ran into a decision point, the main question we tried to always answer is, if we move into this new world of cloud, are we better than how we were operating before? If we aren't, then we have to go back and refactor. Right? So the two outcomes that we tried to impact were focused on the test side, the testing organization side, mainly on the test automation framework and the tests themselves. Right? But to begin, let me start with some assumptions. Right? We are going to assume that all the right people in your organization took time to re-architect the application and refactor it to be all the good things it needs to be cloud native, right? So including being stateless, having service meshes, deploying, containerizing the application, deploying it through orchestration, everything happening through a highly agile DevOps automated function around automated provisioning, short startup and shutdown times, and also a rollback mechanism. Right? This talk will only focus on how the test organization or the test team tried to adjust or react to everything that was happening around them. Right? And why did they have to adjust? Right? Over a period of time, a huge investment was done in the test suite. There were a lot of tests that had grown over a period of 2 decades. And these tests were good. They were providing reliable automated regression feedback. It was fast feedback. Just to give you an example, like this is one of the test pyramids for one of the groups. If you add them all up, right, you can easily imagine that we had over 70, 80,000 tests that were built over that time. So how do we take advantage of also moving to cloud, but also preserve what we've built over a period of time? So we'll start with the test framework. And the three main things we tried to focus on, or we felt were the most important things, was around handling secrets. How do we do logging and the cost considerations? So I have a paper which is linked to this talk. So this paper will talk about the challenges around these three things we faced, beginning with handling secrets. Right? So every app, every service that you build today requires secrets to enable the right level of access. It could be tokens, certificates, keys, connection details, root passwords, root accounts, and all of this we wanted to make sure that we do this through the test framework and not have anything in the tests themselves. So that was one main consideration for secrets. The other part around secrets was that in the on-prem infrastructure, everything is a physical infrastructure that's housed in a DC. So everything happens on an internal network. Whereas in the cloud, our choice of the cloud provider was AWS. So in AWS, everything happens natively. So what we were trying to do is all this capture and store of secrets that is happening over the AWS. There was a risk that it is still transmitted over the internet. So it was very critical to move this into a central management and not have us spreading our secrets through each individual project. The other thing to consider was for secrets, the secrets flow differently in an on-premise world versus a cloud. Right? In the on-premise world, it's all stored on a disk somewhere. So you have to make a connection to the disk to access it. Whereas in AWS, it is native. But what it does is it gives you an advantage that the attack vector is limited to the AWS ingress and egress points. So how do we do that, right? How did we take care of that work? For secrets, right? Whether it is on premise in a data center or whether on the cloud, some of the things are common. How to create them, how to rotate them, how to revocate them, how to expire secrets. So none of that changed, right? So what did change was how we moved everything into the framework. The way to do this is through running a scan on our test repository to find out where all the secrets are. Next thing is to make a decision on those secrets. In places, they've been in there for a long time, not used, so clean up, removed all of them. Some of the secrets were harmless, so we just whitelist them, and then the rest has to move because they are critical. So they have to be created in cloud-native solutions like the AWS Secrets Manager, and then provisioned to a new helper class that can be used in the test. What I do want to show is here's how we decided to scan. We didn't write our own scanners. There is a great tool available in GitHub. It is sort of developed through a community of practice. It was very effective. It's very easy to push into this across the group. So Git leaks gives you a nice report of when you scan your repository of how and where all your secrets are in your test code. And then you can then go line by line, making a decision through that. And then here's an example of how a test looked before we moved to cloud. A test used locally stored JSON file, which had the key value pairs, right? So this is not an actual secret from my company. It's something that's on the internet, on the W3C org site. So I'm just showing you how credentials were being passed, right? So every area, every repository wrote their own authentication manager, and they brought in the signatures from this JSON file as needed for the test. This is one of the things we went and eliminated. Right? So to go back, we didn't again try to reinvent everything. GitHub provided through the AWS SDK a lot of work they had already done. So we were influenced by this and tried to bring in a lot of the similar way of doing rotate, create, revocate, distribute, and other things. So there are these things. This is not our code, but I just wanted to share something that's very similar to how we got this from AWS. I do have these links. Um, in the paper, which is attached to this proposal. So you can access it from there. But what does it look like when we make the transformation? So once we've created that helper with all the methods that we need to be able to do this, every method is defined as a public method. And the test now changes because we wrote a common authentication helper for every repository. All the tests, no matter which teams or squads were running them, would have had to use this authentication helper um, using the AWS SDK. So we now have AWS doing a lot of the work around providing the secrets provisioning function, right? So everything got abstracted into its own module and could be added to every single programmatic test that we have. Right? So it was just a matter of doing a find and replace, and then refactoring the code as needed depending on what you were looking for in the test. So that's the secrets management. The next part is logging, right? One of the aspects of software testing is the ability to debug a failure. And failures happen, for any number of reasons. They happen anytime. We do want to have the logs available to analyze them and create like some kind of a contextual pattern which can help us find them. So we did want to focus a lot for the strategy, right? Again, on-premise and cloud, it doesn't change, right? The strategy, the structure, the log level, the storage, right? So you still have to figure out what to log, how to log, when to log. So if anytime you're working in a lower environment, whether it's dev or QA or staging, you can do excessive logging using info and debug level. It's not recommended to do that in the prod environment because it can generate a lot of excessive data in the cloud. The other thing that is different between on-prem versus cloud is people are used to easily getting access to SSH, getting into the boxes that you're working with and try to do complex test troubleshooting. You can do that in AWS also, but with the AWS heightened security that is there, it's always recommended that you try to capture as much as possible in a log. Right. So how did we go about doing this thing? To begin with, to show you an example of a programmatic test automation framework, I think this is a very common framework. I just sort of broke it down into a very generic way of doing things is like a Java example here. Every framework, every test begins with the name of the test class, followed by a definition block. Then you have the condition block, all the things that you need to run that test, followed by the real meat of the test where the actual execution happens, where you do the test. And then you have the expect block. This is where all the asserts happen, right? And then because it runs at compile time, you have to build it and run it like a Java program. You can have one execute block, one expect. You could have one execute block with multiple asserts, or you could have like a mesh of execute, expect, execute, expect. It could be, depending on how complex your use case is, right? So we did was created a new log helper, just like the AWS helper, to add some AWS specific items, because you wouldn't do this on-prem otherwise, because AWS, the storage is all S3, right? There is no such notion of it on the on-prem stuff, right? You have VPCs, you have query logs, Route 53 query logs. There's a concept called bucket right? Buckets like how you organize your data in S3. So it's a little bit of reading, but if I take the same automated framework, now the test would look like this with enough and excessive logging in it, right? So you would have logging in the with condition block to enable how your Route 53 works, right? Which VPCs, which region. It's going to try and capture all of this, something specific to the cloud. It's also going to print for you, okay, all the Route 53 rules that you're working with. In the execute block, if there's any CRUD operation happening, like a create an object in the bucket, you want to know, if it's happening in multiple VPCs or multiple regions, you can now capture all of that. Again, these are things you wouldn't have done in a regular on-prem test. So, and you would do your regular assert that the object was successfully created, and then also generate the Route 53 log and how things work. So with this, what happens is in the world of cloud, where you have microservices, um, there is a lot of integration at many points. So the failure could happen anywhere. This type of logging actually would help, and it would benefit the team to find out if something was wrong at the infrastructure level or at the application level of what's going on. If I take the first two examples of handling secrets and logs, um, I just wanted to show an example of how a programmatic test automation between two services, there's a data ingestion service in this example. And once it's ingested, there's a query API service that's being called to use some of that for some downstream activity. The end-to-end tests that were written, right, had one monolith helper, which grew over a period of time and had everything in it. And it was done and maintained only for this squad or for this product area. And then everybody tried to do their own helpers. With the change, things looked a little differently, right? With the common, standardized, and consistent way of doing this, the monolith was broken down into keeping the test helper only relevant to the functionality, whereas all the other stuff was abstracted at a higher level, called with AWS secret helper, AWS log helper, S3 helper, which was common across all the teams that were writing programmatic automated tests once we move this to the cloud. All right. Next up was cost. Running the tests in the on-premise infrastructure, like we find it easy, seamless, simple way to do it. But the on-premise infrastructure has, we don't think about cost, right? But it does have a upfront, large upfront expenditure that you have to do. And over a period of time, you don't have any recurring cost, but just whatever you need to do for upgrades and upkeep of that infrastructure. But once we move to cloud, the things change that now you have to be very conscious about what's my spend monthly, daily, monthly, annually. All those things come into the picture. So you do want to make sure that, like I said, the first question we always answered is this new world better than the way we were before? So we have to keep in mind about cost. So to make it easy, we start with base images and how we were doing data initiation for the test, how the environment provisioning was being done dynamically, making sure the tests run parallelly, and not to pay for idle resources, just pay as you use. So I wanted to go through an example about how we went about. So before the decision to adopt cloud, everything looked simple. Was a sequential test automation. Let me remove this. Okay, it was a sequential test automation. Jenkins was the choice of automation tool that was being used. We ran a commit job. that compile, build, and uploaded the package to the repository, and then you ran your tests. They went through the designated agent boxes or to a designated test uh, VMs where the application and the database needed for the applications were always housed. Um, Everything looked sequential, and when we changed it, looks a little busy, but this is this is what helped us reduce the cost and the time, right? So we knew we were going to use Jenkins, but we created a dedicated agent for a parallel test execution job and used Docker containers to take the same hosts that we have and split everything using a Docker engine into containers. So the job of this dedicated agent was to build and run in parallel all these containers where the application was containerized. It used a base image um, for uh, for the OS and other things that you needed to do this. It also had common entry points so that you can initiate each container how you need it for the test. There were special scripts written to distribute the test across, in this example, 10 containers. On the database side, Oracle, uh, they really can't containerize the database, but they have their own containerization way of doing things. It's called PDBs or pluggable databases. Um, it's really cool way they allow you to make one-to-one connection with each containers with each pluggable database. So at the end of it, what happened was the previous job again was providing valuable feedback, was taking close to 2 hours to finish. Um, with this setup, everything was provisioned dynamically. When I needed this, the Docker host VMs and the database VMs got spun up, got provisioned, the test ran, and the infrastructure got deprovisioned. And all my results were aggregated into a time series database and then presented on a dashboard, depending on each package or each group. This took 15 minutes. Now, again, the pay as you use principle. So I could, have as many commit jobs, or I could kick this at a scheduled time, the job, or we could run it every 15 minutes. Now that it takes 15 minutes, or you can do it whenever you wanted it. Um, you can have a listener or a webhook for the commit jobs, and it would kick this off and shut down. So the environment got provisioned and utilized. So this was a way for the teams to take cost into consideration. One of the newer things we're starting to work on now is the left portion of this is the Jenkins agent, and the Jenkins orchestration is still on-prem. So we're trying to move that also into a similar containerized where agents are spun up as needed to do that work. So the framework, again, to summarize, we mainly focused on secrets, logging, and then changing the CI/CD to be a parallel test execution. So all jobs that were freestyle jobs became pipeline jobs, and um, teams were happy because they could run each containers, right? And if a container failed or tests failed in a container, you could then capture it and upload it to a repository, hand it over to a developer who would then post it on his laptop to see what went wrong. So it helped a lot in remediating the problem and getting a fix quickly as well. All right. For the other half of things, I did want to talk about the tests themselves. Right? A very common test strategy would look something like different levels of testing, around functionality testing, or the implicit or the non-functional requirements like performance, scalability, load, resiliency. Um, we did discover that we didn't have to do much here, but there were smaller nuances that you had to figure out in the cloud domain. So I'll talk a little bit about those. One of the things is AWS integration tests. So this is a new suite, a new class of tests that we introduced that we didn't have before. Because in the physical infrastructure, there is a lot of familiarity with the infrastructure where you can, get some sense of confidence of how the underlying system works because you're used to it. Cloud was new, and when you're developing and writing test code or any code on your laptop, this is not something that you can easily plan for or know how things would work. So we created this new class of simple and effective tests that these are API tests where the tests themselves had full control of the behavior they wanted to execute, and we could create one per project or one per package. But this was used mainly to assess the health of the environment. So you run a short test suite or a smoke test suite before you initiate your end-to-end test. And if these didn't pass, you don't run your end-to-end test. Gives you something's off about the environment, right? And because AWS, the way it works is you need to be authenticated first at every stage to get access into AWS. So these tests were that first level of interaction you would do to make sure that, okay, I am going to be successful when I run my end-to-end test. Okay. The functional tests themselves, which were testing logic, we didn't change any endpoints because the logic was still valid. And this is where a lot of the preservation of the existing tests came into the picture. So everything was using endpoints, or if it was a UI or a client, once they became operational, the tests themselves worked. There were smaller changes, but you would do that, as you found bugs and you fix those bugs in them. But otherwise, we didn't really focus much on the non-functional tests. But on the non-functional tests, again, some minor things that you would have to have some special consideration for. So let's begin with performance, which is very important. Performance degradation, that arises from any complexity inherent to the application. It's very difficult to isolate that from whether it's the environment or it's coming from the cloud infrastructure, right? Because the cloud infrastructure does have some virtualization overheads. It is strange, but the performance numbers on premise for the same application will come up differently for the same application on cloud. So the focus was to make sure that the performance tests themselves were targeting the performance metrics that we wanted to capture. And in doing that, we decided to have a focus on specific things like caching, application caching, or or doing what in-memory data store, or read and write through at different latencies. Because when you come to the cloud, latency does matter. When it comes to performance, one more thing to consider is the time of the test, right? If you ran your performance test on a different day at a different time, you're going to get different numbers in the cloud. Again, it's strange, but it happens. So in order to get some level of statistical confidence, you have to do multiple runs, and then you have to gather mean value of those runs and figure out, the variability and come up with a number that makes you feel confident about your performance testing. So I'm not going to go deep, but that's why you also have to consider your customer, right? What's their geographical profile? So if they are going to make a connection to the European region, so is it deployed in the European region, or are you still using the US region in AWS? Sometimes the costs are different, like the US region tends to be more cost friendly than the European or Asian region. So all these things come into the picture to do that. Load testing was another thing, is around the test that you have to determine how your application handles load. In this place, right, the tests themselves didn't change much, but one of the considerations was to run these tests in multiple AWS regions. We wouldn't have done this in an on-premise setup. What you do see is that there are specific regions that might provide you with lower latencies and better performance or better experience. So you do have to consider doing load testing. One other special thing that cloud providers like AWS would give you is the ability to have instances that have their own memory, RAM, storage, and configurations. Like if you're familiar with the EC2 instance, right? In AWS, you can have small, medium, large. This is not available in a data center, in a physical infrastructure for you. So you could decide to run your load tests on, depending on small, medium, or low, and do more comparative load testing on how things would behave. What this would help you with is to know how efficient the application handles load, but also to bring the cost down, right? If you are seeing better numbers with a small or a medium instance, you might want to use that. Whereas in the on-prem, you have these, standard provision racks with the same memory and utilization in them, which also degrades over a period of time. Next up is resiliency testing. Again, service failure and disruptions. These kind of things need handling, and they come at high expensive costs as well as customer dissatisfaction. But cloud infrastructure is inherently supposed to be very stable. Right? Things aren't supposed to fail. Infrastructure is not supposed to fail there. So our plan was to keep resiliency testing limited to business continuity and disaster recovery type of tests. We decided to forego our negative tests or pull the plug kind of tests. No need to do those here. So that's some savings we want to do. So you focus on things like if one service isn't available for another service, how do you ensure disaster recovery or continuity at that point? What happens if the database is full, or what happens if the cache isn't available? So focused everything on that and not on the core infrastructure level thing. So any guardrail testing that we had, we just skipped and went to business continuity. Some of the other things that are specific to tests themselves are application security related tests, like penetration tests. This is different here. So you can't just run penetration tests in the cloud. You first have to understand what is the cloud provider's policy in this. So AWS publishes their, they call it the customer service policy for running these kind of tests, and we as a team have to adhere to it. And then there are some things that they don't want you to do directly in terms of penetration testing. They want you to use one of their partners. And then some things are a no-no, right? Like you cannot do a denial of service kind of testing in AWS, right? That's frowned upon. So they will, they will get back. They'll give you feedback around doing that. So these are some of the things that we talked about in our framework and the tests. Now, every team's different. Everybody is different. This was the experience for our journey. So in the end, like just to say that there's definitely benefit in leveraging AWS because it simplified a lot of the things that we were doing manually or struggling to keep automation up to date for around provisioning infrastructure, access management, secret management, auditing, and like guardrails. AWS does that for you. So there's definitely benefit. It comes at a cost, but you're getting something for it. In terms of our own adoption of this and modification of the framework in tests, we felt it was a marginal increase in effort. It could happen in parallel while we were doing software development and roadmap activities to adjust the framework. We tried to keep everything around the infrastructure also in manageable incremental cost, because it tells you what your cost is. AWS will give you a daily report. You can build in thresholds so that it alerts you to send you a message on your team Slack channel if you spend $10 instead of $8 that day. So those things makes everybody cost conscious. And overall takeaway was that you don't really have to throw away all the hard work you've done over so many years. The rewards were much higher as compared to starting from scratch and rewriting everything, and then taking a hit on building the infrastructure and other things. So that's my experience with this. It's still a continuing journey. Hopefully, this would help on how we handle the story. Others might find beneficial and talk about it, because even though cloud's been around, people still work a lot in data center. It's not guaranteed that cloud will save you money or will always be better for you. But there are times when you do have to make a decision to move to the cloud. So hopefully this experience comes in handy to people. And with that, I will stop. If you have any questions, I'll talk. Yeah. Yes, so they were API tests, they were contract tests, and quick tests, right? Because we do want to know that before I kick off a whole suite of tests, like thousands of end-to-end tests running, like is everything kosher, everything working fine? Anything online? Yeah.
I'm just curious, do you have any influence as to whether you chose AWS or?
No, that was not. I wasn't involved in that. So whoever made that decision, probably went through whatever studies they had to do around cost and architecture to do that.
But it wasn't online.
What tool did the question is? What tool did we use for contract testing? So we wrote our own contract tests with JUnit 5. So that's what we used. I have some examples in the paper that you can look at. Yeah. Yeah, so that's okay. The question is, while we were trying to avoid rewriting the test, did we also do some analysis on whether some of the tests were still needed, and doing that? So that's where that's a good question. So the Git leaks code that we used, that way when we had to go through how many secrets are we using in the test code, none of those tests are packaged and delivered as a product, right? And none of them run against production. So, but we were still capturing a lot of things which would still enable, possibility of a leak or an exposure. So while we were doing Git leaks, and it generated a report against the entire test repository, while we were going through those, and we said, this particular secret has no value, or why are we even using it? It's not being called anywhere. We were also assessing the same thing about the test. Like, what is this test used for? Now it's some kind of legacy code which we don't even have anymore. So that's where those things also started to get filtered out, and we didn't run those. We just marked it with the ignore flag for the test runs. So yes, so this also helped us doing some technical debt cleanup at that time. Yeah.
How were you working?
Yes. Okay. How did we handle a lot of tests? We have a lot of tests. How we grow. Again, the tool that we use, how it was against each repository. Each repository. Yes. You have so many tests, but you also have test points. Did I answer?
Yes. So it's a manual process which we have to divide and conquer. But eventually, this is a one-time overhead that you wouldn't do once all your secrets handling and secrets provisioning and log and other helpers are in place. Everything is now done commonly and consistently for everybody. Yes.
Yeah. How did you go?
Right. So the question is, how did we get teams to do this one-time overhead of adjusting and getting onto this transformation path? Just speaking, our previous speaker, Selena, when she was talking, I think somebody asked the top 3 challenges, and the first one she said was busyness. Right. That is really a challenge. Right. Everybody wants to focus on business and revenue items, new features, roadmap items. So how do we take care of these things? So everything was created as a roadmap item and put together with a time frame saying you have 5 sprints to take care of this. Now, 5 sprints is a long time for you to adjust this and take this work. A lot of it was the test team that was doing this. So whenever they had capacity or when they didn't have anything ready for them to test, they jumped onto this and took care of it. But over a period of time, as you do it more and more, people find efficient ways of doing it. So a lot of the times it was find and replace and then fix it after you've done the find and replace. So it was pretty fast to do that.